Spleen over here. This is a kidney, which is kind of behind the rest of the organs here. Another kidney over here, the adrenal glands sitting on top of those, which aren't part of the respiratory or the digestive system. And this is a piece of the liver, and this is the gallbladder. It's kind of nestled in the folds of the liver. So the pancreas, as I talked about earlier, has three parts to it. This is the duodenum, which is the first part of the small intestine. And this part of the pancreas that kind of sits in that curve of the duodenum is called the head of the pancreas. And then this part of the pancreas that goes across behind the stomach, that's called the body of the pancreas. And then the little tail of the pancreas is right next to the spleen. This tube that you see running through the pancreas is called the pancreatic duct. And it's transporting the digestive enzymes that are being made by the acinar cells inside of the pancreas to the duodenum. So most of the digestive enzymes that go into the duodenum are made in the pancreas. The pancreas is a major organ that produces digestive enzymes. The duodenum itself also produces digestive enzymes, as we'll see on Monday when we come back and we finish talking about the digestive system. This little tube coming out of the gallbladder, this green sac is the gallbladder. The little tube coming out of the gallbladder is called the cystic duct. And that joins with the tubes coming out of the liver. The tubes coming out of the liver, this is called the common hepatic duct, and it's formed by the union of the left and the right hepatic ducts. The two of them come together and they form the common hepatic duct. And when the cystic duct and the common hepatic duct join together and form a common tube going down to the duodenum, that's what we call the bile duct. Some books call it the common bile duct, but I prefer the bile duct because it's not really a common tube. Remember, common in blood vessels meant we had other vessels of the same name. So we do have the left and the right hepatic ducts, which form the common hepatic duct, right? But this one is technically really just the bile duct, but some books do call it the common bile duct. Now when the bile duct and the pancreatic duct get close to the opening that leads into the duodenum, and it doesn't really show this on this model, the two of them join together and they form a common tube that's called the hepatopancreatic ampulla, or I like the old name of it better, the ampulla of Vater. And so that's a common tube that's the union of the pancreatic duct and the bile duct. And then that duct goes into the duodenum, and there's a little bump that kind of protrudes into the duodenum. It's called the duodenal papilla. And inside of the duodenal papilla, there's a ring of muscle, which is sometimes called the hepatopancreatic sphincter, or I like the older name of it, it's called the sphincter of Oddi, right? So I like this because all these names are kind of Germanic, you know, the sphincter of Oddi, the ampulla of Vater. So I kind of like the, you know, there was a concert writer, Wagner, and he wrote The Flight of the Valkyries, you know, da 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 da. You heard that before? Maybe if you watch Bugs Bunny, you know, Elmer Fudd's always saying, I'm going to get the rabbit. But anyway, so I like to use that to remember these. So I say the bile duct to the ampulla Vater, the ampulla Vater to the sphincter of Oddi, then into the duodenum, right? So that's how that material is going into the duodenum. Now you notice inside the duodenum we have little wrinkles, kind of circular wrinkles. Those are called the plicae circularis, which means the pleated circles. And that's one of the things that increases the surface area inside of the small intestine so that we have more surface area for food molecules to be absorbed across. And we'll talk about the other things on Monday. There's three things that increase the surface area, but those plicae circularis are one of the three things. Okay, so that's our pancreas model. All right, the next one we're going to take